Lesson 40, simplifying and evaluating expressions using the power property of exponents. So I'm just going to real quickly remind you, and you can put these power rules on some kind of note card for your test. It would be very wise of you to do so. So here are some of our power rules. These are all ones that we should be comfortable and familiar with by this point in our algebraic careers, but never hurts to get a reminder. So anything to the 0 power is equal to what? 1. Okay. If we multiply things with like bases, we do what to their exponents? Multiplying things with like bases, we do what with their exponents? Add them together. Good. When I divide things with like bases, I do what to their exponents? I subtract them. Good. Now, here's the last one. If I have something with a negative exponent, how do I make it positive? Not quite. I need to put it where? I'll give you a reminder. There's a fraction mark. I need to put it over, or put 1 over it, right? So basically, I move it on the other side of the fraction. So let's do another example of that one. If I have x to the negative n and x to the negative m, and I want to move them both to make them positive, I would basically do the reciprocal of it. So I would have x to the m over x to the n, and now they're positive because I flipped them both. Okay? Any questions on any of those? Awesome. Just as a reminder, if we have something to the first power, it is just that thing. It is by itself that thing. Okay, let's get into a new rule that I don't think we have gone over just yet. What happens if I have, say, 2 to the third, okay, I have 2 to the third to the second. I have a power to a power. What do you think? Remember, we have, when we multiply things with like bases, we add their exponents. When we divide them, we subtract them. So what do you think when we have a power to a power? Right, yeah, if we were trying to go ahead and solve it out. What if I told you x to the third to the second? And I said simplify that. How would you do that? Let's expand it. So let's expand it. It's x to the third twice, right? So it's x to the third times x to the third. Would you agree? Because what's in the parentheses is being multiplied by itself 2 times, right? So it's x to the third times x to the third. But now I have things with like bases. So what do I do to their exponents? I would add them up. Now, what would be a simpler way to get from here to here? I would multiply their exponents. So here, I would do the same kind of concept, 2 to the 6th. And then if I wanted to expand it, it would be 2 times itself 6 times. But for the most part, we're not going to expand them if we don't have to. Okay? So now we have a new exponent rule. It says when we take an exponent and bring it to another power, so an exponent to an exponent, or power to a power, we end up multiplying those 2 powers together, m times n. Okay, so we'll add that one to our repertoire. Cool? This will not work when x is 0. We try not to mess with things of base 0 too much for the time being. We will not mess with that. So example 1, we'll just get straight into it. On A, it gives us, and it just says simplify each expression. It doesn't say solve, it says simplify. So if I have 2 to the third to the second power, we just did this one, what is the answer? 2 to the 6th. Good. On B, it says, what if I have a to the 6th to the third? My answer will be a to the what? So 6 times 3 is indeed 18. Let's do a more complicated one. So here, another rule that we're going to end up adding up with our exponent rules. If we have something multiplied by another something, and that's raised to a power, m, then we basically do a distribution. We distribute it to the y, and we distribute it to the x. So it would look like this. X to the m and y to the m. So the more common thing that you will see is, let's say, 2x to the third. So you'll see this quite a bit. And in our answer, it'll be 2 to the third and x to the third. So each thing gets a third. So let's transport this rule up here. xy being to the m, xy to the m. We're going to distribute out our m to each piece. It gets x to the m and y to the m. Okay. So I want to expand on this one really quickly. If it was 2x to the third, that means it's 2x times 2x times 2x 3 times, right? And if I rewrote this using the commutative property of multiplication, I would have 2 times 2 times 2 and x times x times x. And using my power properties, multiplying things with like bases, I get 2 to the third and x to the third. This is just a shorter way to do this without having to expand it out. So this is not math magic. It is using the properties that we already have to be able to get to that point. Okay, so on example 2, we're going to start using this property. We have 7, a to the third, b to the fifth, and that's all going to be raised to the third power. Okay, so I'm going to start with the 7. I'm going to give the 7 a 3 to the third power. I'm going to give this a to the third a 3. So what does it become? What's 3 times 3? 9, good. And b to the fifth gets a 3, so it becomes 15th, good. So this would be our final answer unless it asks us specifically to go all the way to the end. So let's go ahead and find out what 7 to the third is. What is 7 to the third? 343. And I can't do anything with the rest of this, so I'm just going to leave it. A to the 9th, b to the 15th. And that's our final answer right there. Yeah, to the 15th and to the 9th. Yeah, even if they were really small, they'd end up being really large at the end of that. On B, gives us negative. Now this is where it gets a little bit tricky. That negative is just like a negative 1, okay? So we have negative 2y to the fourth raised to the third power. When I give this 3 out, I'm going to write it very specifically so that the negative 2 is still in parentheses. Okay? Because the negative is inside the parentheses here, I want the negative inside the parentheses here. So give this 3 to that piece, so it gets a 3. And then give this 3 to that piece, and I'm going to get y to the what? Say that again? 12. Good. So now I need to simplify this part. So if we're going to use our calculator for this, and some of these you will, you have to put in the parentheses. If you don't put in the parentheses, sometimes, especially with even exponents, you will get them wrong. So practice it and do it every time. Parenthesis, negative, not a minus, negative 2, close parenthesis to the third. What do I get? Negative. Good. Negative 8 to the, and then y to the 12th. So that would be my final answer right there. Questions there? Example 3 then. Oh, it's at the very bottom of there. Okay, example 3 says application of interior design, and then they give us this picture. It says it's 2x, so twice the amount basically is what it's saying of feet, and then twice the amount of feet over here as well. So basically they're saying they're wanting to increase each side by twice as much. So a square family living room is being measured for carpeting. If the length of one side of the room is 2 times the amount of feet, what is the area of that room? So we're going to write our area, and we're going to have to leave it in the form of x because they don't tell us what we're plugging in. So how do I find the area of a square or a rectangle? Base times height is what I heard. So a square or a rectangle, we always go base times height. So what is my base? It's 2x, right? And what is my height? Again, 2x. So using the commutative property, I'm going to put the things that are alike together. So I have 2 multiplied by 2, and then I have x multiplied by x. So when I reduce this, I get 2 times 2, which is just 4. And then I have x times x. What do I have now? X squared. And then I need a label. So our label is definitely going to be in feet, but it's feet squared, right? If I would have wrote this all the way out, we would have ended up with 2x feet times 2x feet. And then when I put them all together, it'd be 2 times x times feet times feet. So that's where that feet squared comes from. Okay? Any questions on that one? I know it's weird multiplying things that don't make sense. Nobody measures in 2x. But sometimes they're going to give you these problems that say a family is wanting to increase the size of their living room by twice as much. And then you'll have to run that simulation. But they won't give you the size of the living room. They just want you to find a general formula for it. Okay, one more power property, and I think that'll be the last one we go over. And it's pretty much the same as the last one. It's a distribution. So if we have x over y to the m power, each of these things get an x, or sorry, get a m. So when I distribute this out, it goes to the bottom and to the top. So x to the m and y to the m. It's basically how that rule writes. So go back, add that into your power rules. We have x over y to the m equals x to the m over y to the m. And now I'm going to give you a more basic example of how or why this works. Say we had, say, x over 2, and that was raised to the third power. Okay? If I expanded this, it would look like x all over 2 times 2 times 2. And then I'd multiply it straight across, right? So I'd get x times x, which is x to the third. And I'd get 2 times 2 times 2, which is 2 to the third, or 8 in this case. So it just gives me a simpler way to get from here to here without having to do this. Okay? So it makes our life somewhat easier to distribute this out. Okay? That's all they're trying to do with all these rules. They're not trying to confuse you or anything. They're just trying to make your life easier by not having to do these extra steps. Example 4. Simplify each expression. We have 2x over 5 all raised to the power of 2. So, keeping in mind that I have to give this 2 to each of these pieces and this bottom piece, let's rewrite this expression. I get 2 squared x squared over 5 squared. Now I need to simplify this out and go ahead and multiply the exponents that I know how to do. So 2 squared is 4, x squared I can't do anything with, 5 squared is 25. And if I can reduce it at the end, I will, but this one I can't reduce, so I'm going to leave it just the way it sits. Any questions there? Okay. The hard part there is, I know I tell you the rule is just give it to each piece, bottom and top, but you have to give it to each piece on the top and each piece that's on the bottom. So if there's 1, you give it to 1. If there's 10, you give it to 10 of them. So that was A. This will be B. We have a negative, and again, this is where it gets tricky. Negative x squared over 3y to the third. And this is all to the fourth power. Alright, so if I see this negative here, I'm going to deal with this negative like it's a negative 1. Okay, because I want to get rid of that negative. I'm going to deal with it like it's a negative 1, because remember, there's always an imaginary 1 coefficient in front of every variable. Because when you multiply things by 1, they are just that thing. Okay, so I'm going to start my distribution. And I'm going to leave that negative 1 inside of a parenthesis so that when I type it in my calculator, if I type it in my calculator, it makes sense. So 4 goes to the 1, so there we go. And then we have x to the second to the fourth, which is x to the 8th. Good. Now I'm going to need to give it to the bottom, so I get 3 to the 4th, and I get y to the what? 12th. Good. So now I've simplified my variables already, so I'm just going to rewrite them really quickly, and I'm going to deal with the number parts. So what is negative 1 to the 4th power? Yep. We put it in parentheses. If you don't put it in parentheses, this is good practice on a calculator right here. It's just 1, right? Because negative 1 times negative 1 is 1. And then 1 times negative 1 is a negative 1. And then we have one more negative that we have to put in there, and it changes it back to positive. So I get a positive 1, right? So I take my positive 1, and I multiply it by x to the 8th, and I get x to the 8th. So in essence, the negative is now gone, which is really nice because I don't have to deal with it anymore. Makes this positive. What's 3 to the 4th? 81. Good. And that will be my final answer since I cannot reduce anything anymore. Questions? Okay, they're going to give you a lot of these types of problems. These are probably the most common ones that you'll see, so make sure if we have questions we ask them. 4xy squared in parentheses to the second power multiplied by 2x to the third y in parentheses to the second power. So here we go. I'm going to do my exponents first. I got to get rid of those exponents because I can't do anything inside of my parentheses. So my 2 goes to the 4, my 2 goes to the x, my 2 goes to my y. So I get 4 squared, I get x squared, and I get y to the 4th. Here I do the same concept. I give it to the 2, so 2 squared. I give it to the 3, which makes it x to the 6th, and I give it to the 1 that's right there with my y, so I get y squared. Now I want to simplify this as much as possible. I want to put the things that are like each other next to each other. So I have a 4, which is just a constant to an exponent, and I have a 2, which is a constant to an exponent. Then I have an x base, and I have an x base, and then I have a y, and I have a y base. So I'm going to put the things with the matching shapes or the matching underline together. So now I have 4 squared, and I have 2 squared. I'm going to go ahead and mark those out as I write them down. I have x squared, and I have x to the 6th. Mark those out as I write them down. I have y to the 4th, and y squared. Mark those out. I've now gotten rid of everything in the slew of numbers. This is a kind of short one, believe it or not. So you're going to see these really long. Now I want to combine everything that I can. If they're like bases, I just add their exponents. So my y's right here, I have 4 and a 2, which make a 6. I have a 2 and a 6 for my x's, which make an 8. And now the question lies with, what do I do with this up front? I just go ahead and multiply them. I have 16, 4 squared is 16, right? And I have 2 squared, which is 4. So when I say multiply them, I say do your exponents first, because order of operations dictates that we have to do our exponents before we do our multiplication. So exponents, 16 and 4. Now I can do my multiplication. 16 times 4 is 64. Okay, and that will be our final answer since there's nothing else to combine. Any questions? All right, that's all you need.